This particular PowerPoint presentation deals with the parabola. A parabola is a collection of points P in the plane that are the same distance from a fixed point F as they are from the fixed line D. The point F is called the focus. The point F is called the focus of the parabola. And the line D is called the directrix. As a result, the parabola is a set of points for P where the distance between F and P is the same as the distance between P and D. So the distance between the focus and the point on the parabola is the same thing as the distance from the point on the parabola to the directrix. So let's sort this out by looking at a graph here. So there's our focus point here, F here. And that's our directrix D here. Now take a line segment perpendicular to the directrix and intersect with a line segment from the focus will be the same length. This will be a point on the parabola. So there will be somewhere out here, there's a point where it's the same distance from that point out here to the focus will be the same distance as it is from that point out here to the directrix. Okay. Now this here is that's our vertex here. So you can start out by seeing it. That's our first point on a parabola. So we're looking at a point that's the same distance from the focus to a point on the parabola as the point on the parabola is to a point on the directrix. It's the same distance from here to here as it is from here to here. And if we string out the set of points, that'll be a parabola. Another one, the distance from the focus to a point on the parabola. From the focus to a point on the parabola is the same thing. The distance from the point on the parabola is to the directrix right here. And we have another point, and another point, and another point. So it gives us half a circle there. And by symmetry, we can get the other half down here. So each one of these points here, if that's the focus here, F, the distance F to P, a point on the parabola, is the same distance from that point on the parabola to that directrix, that line here, that same distance. And that defines a parabola. Based on this definition and using the distance formula, we can get a formula for the equation of a parabola with a vertex at the origin. The vertex is at the origin and opens to the left or right. And that's that formula there. This is a formula for a parabola with the vertex is at the origin and opens to the left or to the right. Okay. In this case, A is the distance from the vertex to the focus, or opposite the way we saw the directrix. Okay. If the coefficient for x is positive, it opens to the right. The coefficient for x is negative, it opens to the left. Okay. So this is what we're talking about here. So they already told us that the vertex is at the origin here. A is the distance from the vertex here to the focus here, and there's our focus from before, and there's our directrix here. In the opposite direction, A distance is going to come to directrix here. In this case, if we're looking at this graph, A is what, 3? So in this case, the equation for the parabola is going to be y squared is equal to 12x. Y squared is equal to 12x. It opens to the right. It's positive here. Okay. And the vertex is 3 units away from the focus. Let's find the focus and the directrix of the parabola. So here we have y squared is equal to a negative 16x. We could put this underneath it here and identify what 4a minus 4a is here, or 4a is. This is our 4a here. So 4a is equal to minus 4a is equal to a minus 16. And that means that a is equal to 4. So minus 4a is equal to minus 16. Minus 4a. And solving for a is 4. So we know what our a is. We know what the origin is. The vertex is. Okay. In this case, the coefficient is negative, so it opens to the left. From the vertex, count 4 in, and that'll give us the get the focus. So we count 4 in here to get to the focus. We count 4 units in, and then what's the location of that point? Negative 4, 0. Okay. The directrix is a line located the same distance in the opposite direction. So 4 units in the opposite direction will give us the directrix here. That's our directrix here. Okay. And from there, we could make a line segment that goes through the focus of the parabola and make it parallel to the directrix with endpoints on the parabola. So we can draw a line segment through here and make the endpoints on parts of the parabola. And this segment is called the latus rectum. There. Okay. So the length of the latus rectum is 4a. So if we know a here, and this is 4a, this length here, so half of that is 2a here and 2a here. That's 4a. So just knowing a little bit of information, we can go ahead and graph the line. Because we know what the vertex is, and using the focus and the latus rectum here is 4a. We know what a is, so we can go up 4 times that, and that location will be a point on the parabola. Go 4 times below that, and that'll be another point on the parabola. So we can actually start sketching the parabola from there. So the length of the latus rectum here is 16. So it is 8 each way from the focus. So 8 units up here, 8 units down here. Okay. All right, so this is minus 4 here. So up 4 will be minus 4, 8, and down 4 will be a minus 4, minus 8. So we have the 2 points that are on the parabola. And we know what the vertex is. And then we can sketch a slight graph of it. college algebra, you learn about parabolas that open up or down. The only difference is with the equation is the x and y are in different places here. Let's look at the steps to graph the parabola. X squared is equal to minus 4y. Okay, so in this case, the center is at the origin. Here. Okay. In this case, we have our focus, 1, so we go down 1. Our A is 1, so we go down 1, and it gives us our focus. We know that. We know that our lattice rectum is going to be 4A here. So we can go 2 in this direction and 2 in this direction here to get other points. The location of this point will be at -2, -2 minus 1 and -2, -1. So this is the lattice rectum here. And we have our vertex. Then we can do a rough sketch of a graph there. And there's a rough sketch of a parabola. If you want to, you can add the directrix. It's not necessary here. So we have our vertex here, and 1 below the vertex is going to be the focus, and 1 above A is going to be the directrix here. There's our directrix. Our parabola may have horizontal or vertical transformations. This would translate the vertex from the origin to some other place. The equations for these parabolas are the same, but H is the horizontal shift and K is for the vertical shift, and it gives us 4 different varieties here. Okay. The vertex is at HK. In this case here, what's being squared? X squared here, and that's positive, so it opens up. In this case here, we have x squared, x being squared, and it's negative, so it opens down. In this case here, in the bottom corner, y squared, and you have this is positive on the other side here, so it opens to the right. In this one, you have y squared, and it's negative here, so it opens to the left. So you might want to take a picture of this and write it down. So let's try one. You have y squared here, and it's positive, so in this case, it opens to the right. Y squared, and 8 is positive, so it opens to the right. All right. So from here, we can, our vertex is going to be here at HK. We have our x there, -1 here, and a +2 there. So there's the vertex. So we can plot that point. That's the vertex of it. So it opens to the right. Okay. And with that in mind, we can find our focus. So 4A is equal to 8. So A is equal to 2. So the focus is 2. So it's 2 away. So it opens to the right. So we go 1, 2 to get to our focus here. And there's our focus. Okay, and length of lattice rectum. So it's equal to 8. So it's going to be 8 here going up. This is that. So half of that will be 4 up and 4 down. So we'll go 4 up from 2 y equal to 2, and going up 4 makes it a 6. From 2 going down 4 makes it a negative 2. So you have points on the parabola and you have a vertex. You can do a rough sketch of the parabola from here. The directrix is going to be in the opposite direction of the focus, the same distance. And A is 2, so it'll be over here somewhere. And there it is. There's your directrix. And there's a little sketch of the parabola. Okay. The secret to doing these is not to memorize a bunch of formulas given in your book, but to draw a picture. When we're given the focus of a parabola was negative 2, 2. So we have the focus and we have the vertex. We can draw a picture of it. So we have the focus. We have our focus here. And we have the vertex here. So if the focus is on the inside, it's going to open to the right. Okay. So it's going to take this form here for the parabola. All right. Now, the unit in this case here, the distance from the vertex to the focus is going to be our A, and we count 1, 2, 3. Looks like 3 units for our A. And based on this here, you can see what your center is going to, your vertex is going to be. You can plug in and plug in, so you can see where your vertex is. A, the focus is 3 units away, so A is 3. So A is 3, so you're going to have 3 times 4, which is 12. Okay. And there's your equation for the line. All they wanted here, figure out what the equation was going to be, given the focus and the vertex. And there's your equation. The equation we are given may not be in standard form. We have to use some completing the square like we did before. So you want to get your y terms on one side and everything else to the other side. So half what 2 numbers when I'm half of the y term here and square it. Half of 2 is 1 and square it, put it there, which is 1. And what you do to one side, you do to the other. So I took half of this 2 and squared it and put it there and there. Then I rewrote this in a factored form. Factors of 1 to add up to 2, 1. And that's what it looks like there. Okay. So now we have it in standard form. We can find the vertex, focus, directrix, and the graph. So you know that 4A is going to be in there, and you have the center there. You have the vertex there. So this is y squared, and it's positive here, so it opens to the right. Okay. The vertex is going to be at what? -1, -1, looks like. Opposite of these values, opposite. So the focus, okay, in this case here, we have a 1 there. So 4A is equal to 1, so our focus is going to be back 1/4. Back a quarter unit from our vertex. So going back in a quarter unit will make this what? A -3/4 x -1 looks like. So we have a -3/4 x -1 here for our focus. Okay. The length of latus rectum, that's going to be equal to 1. So you go up half a unit. So it's going up half a unit. So that'll go up to a minus 1/2 here. So it'll be a minus 3/4. Minus 1/2 going up, and a minus 3/4 and a minus 3/2. So you can see it here. That's what it looks like there. Going up a half each way and down a half. And that's what happens there. So you have points on a parabola and you have a vertex. You can go ahead, you could sketch a graph from there. The rectrix is going to be in the opposite direction of the focus, a distance. In this case here, it'd be 5/4. 1/4 away from the vertex, so it'd be a negative 5/4. And there's your directrix there. And there's a sketch of the parabola. Okay. Many applications involve using parabolas. One is paraboloids of revolution. Taking a parabola and spinning it, making it into a dish. So the waves come in and hit the surface, are reflected to the focus of the parabola. Here, the central point at the focus. They put a little microphone there and listen to it like a parabolic microphone. And that finishes this one.